Well, again, Kevin Call, PM Head of Cloud Management Software and Solutions here at Supermicro, continuing our video podcast on NVL72 monitoring and management of a rack configuration. So in the previous video, we looked a little bit at the rack management of the special design of the NVL72 rack. We're going to continue to keep looking deeper into each of the various different quadrants that we talked about, compute tray, the in-rack CDU, the power shelf, and the NVL link switch. So you'll notice here on the left-hand side, there are options here to look at each of these quadrants in detail. So we're going to click on the compute tray here, which is certainly going to provide you with compute list tray information. So all of our compute servers that are in the NVL72 will be in this list. We just happen to have one, so we have a partial kind of configuration here within our lab that we're testing on. But in a real production environment, you'll see a number of the compute tray list showing up here. You can see here we provide the location of where this is. It's in a default rack configuration, but if it was associated with a group, the location information would be here. We also specify the IP address, so you can click on this particular link to drill into the BMC of that server. Product SKU information, which is the SKU of the server itself. This task is to indicate anytime you deploy an operating system or perform tasks, they will show up here indicating that the task is running or it's been sort of generated to the back end as a scheduled task that can be working in the background as you continue to flow through the front end of the GUI. We have a power status of being on here, health roll up, which is in this case is showing critical, uh, a socket count of 2 and a memory size of 1024 GB, and tag management. Tag management would be if you deploy a specific operating system to this server, we associate a tag there to indicate that the operating system was deployed. You can also define user-defined tags as well. This is no different in the previous air-cooled solutions or liquid-cooled solutions we have, so nothing special there. Same kind of functionality is built into the NVL72 rack configuration. On the top here, you'll see here our standard lifecycle management that we can perform on this server, such as powering down the server, forcing off, forcing reset. So all of these commands are sent through Redfish subscription services to the BMC, which is the source of truth, to perform this particular operation of shutting down the server. Each of these options are available to you. The ability to blink the UID if you needed to do so. Perhaps you have a number of these racks within a data center and you're trying to determine that a specific compute tray or compute server is having problems. You want to identify that. So you go out and physically inspect it and see basically what's going on with it, or basically pull it from the rack to do some type of maintenance work on it. The ability to do firmware updates, which is a little different here with the NVL72 configuration. We now support bundling of firmware for an NVL72 rack. So this is good news for a lot of the folks that are supporting Nvidia NVL72s, that we have the ability now to bundle firmware and initiate a firmware bundle update to the entire NVL72 configuration, which is the compute tray itself. And then we also are able to update the BMC too as well here with a flash of the BMC to bring it to a newer version or newer cadence release of the BMC. Um, the other thing is, moving on, we have the ability to click into the Compute Tray website that's connecting into the BMC itself. You'll see detail here. So if we selected this and wanted to look at the detail, we can click here, and then it will show us information about this compute server, such as the name of the system, the UUID, manufacturer model, SKU, serial number, so on and so forth. So we can continue on through here and look at other options such as boot options, processor, so on and so forth, which we'll get into a little bit more detail a little bit later in this particular podcast. Memory size, and then resources, right? Which is the resources, again, are Redfish endpoint queries that we collect this information being the source of truth. And in an NVL72 configuration, it's OpenBMC. So we collect all these endpoint schemas and basically package it up and unify your experience as a DevOps administrator, adding all the appropriate metadata, making your job much more easier to support large AI infrastructure or large AI super pods or AI factories, right? Which is important, right? Especially with a management enterprise platform like SuperCloud Composer. All right. So moving on to the other ones here, we have the ability to reduce the size of the table. Again, this is nothing different, right? We can click on each one of these and enlarge the size of the table. And you can see here that our table has now gotten larger with pertinent information here. Um, and so if you wanted to sort of collapse the table, then you can simply uncheck these and the table is reduced in size as far as the columns and things like that. So you have the ability to customize your particular table list because again, when we start looking at this, it can become very large as far as the compute tray list for showing a number of servers when we get down into the compute section here, which really shows all the servers that have been registered within SuperCloud Composer. So this is nothing different, right? We did this in other previous releases for air-cooled solutions, for general enterprise compute, or in an AI infrastructure such as a B200 use case for Blackwell compute or any of the H200 use cases and so on and so forth. So we've used the same methodology, the same initiative to bolt it across the entire platform to be able to customize your element lists to look at various detailed information you want to look at or that you're trying to make those data-driven decisions. So that's on the compute tray. We'll go down to the next one, which is the in-rack CDU. The in-rack CDU is much different in a general say liquid-cooled H200 use case or MI300. The in-rack CDU has now been optimized for a lot more capability and functionality to support a lot more flow as far as fluid is concerned, a lot more cooling optimization within the in-rack CDU, specifically for B200 use cases and NVL72. So going through the list here, we can see location, IP address, and we'll get into in-rack CDU status in a few moments, collecting sensor data for leak detection at a CDU level, those sensor points. And we'll talk about that a little bit later in this podcast. You'll be able to look at the top power unit, the bottom power unit, product SKU serial number, and firmware version of the CDU. And on the top here, you can flash the firmware update of the CDU with giving it to the latest revision if you so need to. With the new revision that came out by Supermicro, you have the ability to flash that CDU. And then also you can click here to get into the BMC of the CDU and look at other information that you need to look at. So the idea here is to provide a platform to minimize the number of clicks it takes to get the data you need to make those data-driven decisions. So does it mean that you have to click into the NRAC CDU because we provide you additional information there? No. I mean, we provide pretty much all of those APIs and that metadata within the management enterprise solution we have for SuperCloud Composer. So you as a DevOps administrator, we're trying to save you time of minimizing those number of clicks it takes to make those decisions and get the appropriate data you need to perform lifecycle management for your AI infrastructure. All right, so moving on to the next one is the PowerShelf information. You can see here we have a list of PowerShelfs that are in this particular rack NVL72 configuration. You can see here the location, the IP address. Again, you can click on these to get into the BMC of the PowerShelf to perform any type of functionality. You can see here that the product SKU information here is the PowerShelf information, the health rollup, the state, serial number, manufacturer, and firmware version will get to as far as exposing that. So again, this is a DevOps environment, so some of these things may be missing because we're still working through development on the release that we're planning to release by the end of March here into April. We'll have a production release. So we're doing our testing today in this and having them in validation here. So some of these fields might be missing data, but we'll make sure we take care of that on the production release and get those fixed. All right, so that's from a standpoint of the PowerShelf. Again, you can click up here and get into the PowerShelf as well to look at various different information we want to look at in the PowerShelf configuration. So moving on to the NVL link switch. So we have just one here within our configuration. At this point, it's powered down. We provide you with the IP address to be able to get into the BMC of the NVL link switch, product SKU information, power status, health, state, serial number, manufacturer, and BMC version. And again, the ability to obviously click on this and get into that switch web GUI or BMC of that switch. Okay, so that basically does it for an overview of basically the rack configuration. So now we're going to drill down to each one of these and look at very detailed information about this appliance that's inside this rack. So by clicking on that one to the left side card or the menu option there or the options for the side card information, you click on that and we provide you with physical asset information associated with that device, right? So if you click here to the tree view, you see here we've gone into essentially the tree view configuration, right? And so when we want to look at this, we're looking at it from a standpoint of providing lifecycle management for your device or appliance here. And so by clicking here, we're going to look at the compute tray detail itself. You can see here that we have other options available to us, indicating processor. So the processor is a Grace type of model, and the total core is 72. We have the state is enabled and a health rollup. So we're showing you basically a 2-socket type of configuration for this particular server. Socket 1 and socket 2 shows you information there. If you wanted to look at memory information, we show you memory information that is in each of those locations. And so that information is showing up here, indicating the part number, the location of that DIMM, and the size, device type, serial number, manufacturer, and health. We also have adapter information here. This happens to be a GB200 configuration, NVL72. So our accelerators that are present in this configuration, we show here on the, we have 4 that are basically installed in this particular server. And you can see here, if you want to look at information, you can see that the manufacturer is Nvidia, the model is GB200, PCI TPIS Gen 4, so on and so forth, health roll-up lanes, so on and so forth. So all the data is basically there to you. And then we'll look at also sensor information associated with this server, indicating various different temperatures that we expose based on lower critical, lower warning, current values, upper warning, and upper critical. So all of the data is basically there showing you that. We indicate the status too, indicating if the health roll-up is sitting at a critical because we have, say, an over temperature alarm or something like that. Any of these type of alarms will be present within this actual configuration. So that's in a nutshell the compute tray. We're going to dig into now. Let's look at the CDU itself, right? So by clicking here on this option and using the navigation, we now can look at sensor data specifically for this CDU. So we see here the coolant return temperature, coolant supply temperature, the update time when we last received an update poll from the BMC. We'll show you information here about manual operation control unit, sensor module. So complete lifecycle management, how operationally this CDU is performing. And we have 2 types of leak sensors here on the front, which we'll talk about a little bit later, that represent a shutdown condition when a leak is basically detected. We hope that there's never a leak, but we built into our product the ability to do leak detection at a CDU level. We have the coolant return temperature here as gauge meters for 28.22. So these are real-time values that we're actually pulling from the CDU itself. And then we're showing sensor data here as well for pump, valve, pressure server, and temperature, and so on and so forth. Scrolling down, coolant flow rate, dew point, and heat load. So all of these sensor data are important to the functionality and operation of your NVL72. We provide that data to monitor and manage lifecycle management specifically for the CDU. So we've talked about the CDU, we've talked about the compute. Let's now talk about the NVL switch, right? So the NVL switch itself is showing up here in the configuration, and by hitting the navigation, we can look at port information. We haven't quite completed that little development work there, but we will show you basically port information that exists within this NVL switch. Likely because this is shut down, that's why we're not showing that information. If we were to power it up, we would likely show the information that exists here because we would be communicating with that switch and pulling Redfish endpoints from that switch configuration. And then sensor data here. Sensor data at one point in time was collected for this. As the last poll, we see BMC temperature, good status, and then various other sensor data that we can pull from that NVL switch. All right, so we've talked about the CDU, we've talked about the NVL switch, we talked about the compute tray. So last but not least is the power shelf. And so we click on the power shelf, we look at physical asset information. We can see here, you can connect into the PowerShelf BMC, and we can also look at power unit information here, indicating we have 1, 2, 3, 4, 5, 6 power shelf configurations here, showing you in good health the state, the serial number, model number, firmware version, and power input in watts for each of it. And let me click here. Yes, we are actually pulling some sensor data for the power shelf. So indicating, showing you information about the power shelf itself, and collecting lower limits and upper limits and the current value settings and memory utilized, storage internal, and various other metrics we're collecting as far as sensor data for that power shelf. So that concludes basically for the first particular rollout of our NVL72 rack configuration. There'll be other videos to come as we continue to learn about new requirements coming in for customers. We have quite a few early adapters that have taken NVL72 into their POC, and we're learning from what important requirements they're looking for to build into our SuperCloud Composer product. Uh, that concludes this video today that focuses on lifecycle management for an NVL72 rack configuration. Thanks for joining today. Have a great day, and we'll see you next time.